Hello, ladies and gentlemen. My name is Mr. Marash. I'm going to be your chemistry teacher. Just want to clear the air real quick. I will not be doing any Google Meets live in person. And before you freak out, the school is well aware of that situation. It's just there's a lot of things going on in my life, my personal life, as well as I'm sure many of you have dealt with or probably still dealing with, whether it's honestly COVID related or not. And it makes it really difficult for me at the moment to do that. So I'm going to stick with the model that I was actually doing in the spring, which I'm sure you'll find is a lot better than what you were used to. Many of my students often said to me during that time when we left school in March that this was the only real learning they felt that they were taking part of. And I don't really believe that, but it's just nice to hear that this works. And I think you'll see that. So I'm going to make these YouTube videos every day. The expectation is that you watch them. They'll be timed. They will not surpass 12, 13 minutes, which is pretty much typically what you would expect to be seeing in the Google Meets. And then I'm going to ask you to try a Google form that's going to give you feedback on those questions, which is all going to be based off of exactly what I teach you in a short mini lesson. I encourage you to take whatever information I give you with you. Don't try and quiz yourself. There's no reason to quiz yourself. This is all new information to you. Well, maybe not at the beginning, it's not going to be, but as we get further and further into the curriculum, it's all going to be new. And so I highly encourage that you just take this with you and use it as a cheat sheet, essentially, to make sure that you're understanding what the question is asking, you're diagnosing what we've written down and what we've just learned, and we're taking what we've just learned and applying it to the questions, which are all Regents-based questions, which is exactly what you need to prepare yourself for. So without, talking too much more, let me give you your first lesson about chemistry. The first question that always comes up when people ask about chemistry is, what is it? What does it mean? So that's kind of where we're going to start. And you can't really talk about chemistry if you're not talking about the atom. Everything is based off of the atom, and it's magnificent because we can't see it, yet we know so much about it, and we know so much about how it behaves and how it interacts with other chemicals and other atoms, and what that means for either us in our bodies or in nature or in space. Everywhere in this universe relates to chemistry, and that's exactly where we're going to start. So, what is an atom? What makes up an atom leads us to the first question of what is an atom? Now, I've also attached, and I will attach this exact form to each of these lessons. So you can print it if you have a printer. Now, if you don't, that's not a problem because it's never going to exceed one page. So if you just want to grab a piece of loose leaf or a blank sheet of paper and then just keep all of these lessons in successive order, it's going to be just like having a notebook, but right at home. And you can make it. It won't be too lengthy. It won't be too wordy. So what is an atom? I kind of talked about it at the beginning. The first thing that you really should know about the atom is it is the basic the basic building block. Right? It's the basic building block of matter. And if you want a further definition on matter, the definition further on matter is anything that has mass and takes up space. Mass and volume. Anything with mass and volume is considered matter. And all atoms, all things of matter, contain these magical atoms. So another thing that we talk about, it is the single unit, I want to make sure I get this right, of an element. It's the single unit of an element. So you've heard of elements before, I'm sure, right? Hydrogen, oxygen. Some of you might think that water is an element. It's not an element, but anything that's found on the periodic table, which we will talk about, anything that's on the periodic table comes in an atomic form. Those are all, at their very, very basic levels, atoms. It's a single unit of an atom. And because it is a single unit of an atom, it cannot be broken down chemically. And that's a big defining factor of what an atom is. Now, we haven't talked about what makes up an atom, but what an atom is that it cannot be broken down chemically. So I said before, some of you might think that water is an element. It's not. It's made up of H2 and O. It's made up of hydrogen and oxygen. And you actually can chemically separate water into its components of just hydrogen and oxygen. With, well, I won't spoil it too much because we'll get down the road then, but you can make hydrogen gas and oxygen gas from something that is a liquid by splitting those atoms apart that were once what we will call bonded, splitting them apart into just their pure atoms. But you can't do that once you get the hydrogen. I guess that's the point I'm trying to make. Once you have hydrogen, you can't chemically break it down any further. You can nuclearly break it down a little bit more, but you can't chemically break down hydrogen. So these are the three main parts of the things that make up an atom. And I'm sure you've heard of them before. There are protons, neutrons, and electrons. So a couple of symbols, things that maybe you haven't heard before. Protons, I'm going to go through them like this because I think it will help, and then we'll kind of summarize it afterwards. But we'll talk about all the symbols, then all the charges, all the masses, and where they're located. So the symbols for all of these things have two separate symbols, at least as far as the regions is concerned. A proton could have a symbol of just a P. It's just that simple. Or it can also have a symbol of a plus sign. I like to put a circle around it. The regions tends to put a circle around it. So those are the two symbols for a proton. Anytime you see those two things in a sentence or in a question or in a reading, it's talking about a proton. Neutrons, bet you wouldn't have guessed it, but it can be written as an N. Wow. It can also be written as a 0. It can also, I guess I should throw this in there too, it can also be written as a plus/minus. And we'll get to why that is, but I think some of you are smart enough to know what that means. Neutrons, neutral, and electrons, unsurprisingly, are pluses and minuses. Okay, so the charges, the symbols kind of lead you to knowing what the charges are, which is nice. But with a tiny little twist. So it's not good enough to just say that a proton is positive. It's not, because we have to specify the magnitude of that positive, and we'll get more into magnitude as we get further down. But how maybe you've heard those silly jokes like, "How positive is it?" or "How real is it?" Whatever those memes are that you kids do these days. But how positive is a proton? It's not just positive. So we have to specify. Anytime we talk about charge, we have to specify the magnitude. And the magnitude of a proton is positive 1. Without this 1, it's incorrect to say a proton is just positive. It's positive 1. Neutrons, they have no charge. I'm not going to sit here and bore you with all the stupid dad joke chemistry puns that I have. It's fine. We'll just get to the point. But neutrons have no charge. Neutrons are neutral. Therefore, neutral things have no charge. Same thing as if we wanted to write this, we can write this again, just like the symbol had said. We can write it as a plus/minus. Cool. Electrons. Again, it's not good enough to just say that they're minus. We have to say that they are -1. Charge and magnitude. Every charge has to have the charge and the magnitude. All right. I'm going to go to now I'm going to do the mass next. So protons have a mass of 1. It's nice and easy. Oftentimes you're going to see this written as 1 U because the Regents likes to, that is a U. It's a fancy Latin U. And that's how it will be written in questions. But the Regents likes to dumb a lot of things down. In reality, chemistry and atoms are measured in these things called AMUs. This is the real unit of chemical measurement for atoms. And that AMU stands for atomic mass unit. Okay? But I may refer to it a lot as AMUs, but just referring to them as U's is apparently fine for the New York State standards. I don't agree with it, but it's what I have to teach you versus what the reality of the situation is. So they are called AMUs, atomic mass units, but by saying a proton has a mass of 1 U, that will suffice. So a neutron, even though it is neutral, it actually does also have a mass of 1 U or 1 AMU. So it makes it nice. Everything is kind of based off of these whole numbers, and that is true. I mean, they're really, it's really not true, but they're so close to 1 that we can just say that they're both kind of equal to the same mass. The crazy thing comes up with the electron is because, according to a lot of science, and it's fine to estimate, the electron has a mass of 0 U. Now, if you're paying attention up here, I had said matter is anything that has mass and takes up space. And so by that definition, it would almost seem that electrons are not part of matter because they don't have a mass. Again, we're trying to simplify it. And even at higher levels of chemistry, it's simplified to this point because the mass of a electron, and I'm going to round up here, is something like 1/2000th of an AMU. That's the real mass of an electron, is 1/2000th of an AMU. And again, we can just kind of, it's so small, we call it negligible. It's so small, it's negligible. It doesn't really matter. It would take 2,000 electrons to equal the mass of 1 proton. And the fact is, no atom has 2,000 electrons. The most electrons that an atom will ever have is 118, and that's pushing it. And then we start to deal with nuclear decay. But I'll save that for later. The point I'm trying to make is it is as simple as saying electrons have no mass. But in reality, which is what I'm going to teach you, which I gave you kind of a preview here and here, is that reality, the chemistry that you are learning is much more complicated or sophisticated than it will be presented to you. But I will show you those tiny little intricacies. So the location is something that kind of just comes with memory for now. Later, as we move down the road, you're going to kind of start to know where things are based off of the behaviors of those specific particles. But we just say that the protons are in the nucleus, the neutrons are in the nucleus, and the electrons are out of the nucleus. Long summer. I think that's spelled right. It's been a while. Yeah, that's good. So in and out. And I like to do this because it really helps you specify the difference between what's in and what's out of the nucleus. So it's almost like a planet. Like if you think about it, let me pull this down a little bit so that you can see this. It's almost like a planet. The nucleus is in the center. This is I'm going to write it here. Nucleus. Right here. And we'll talk about how small the nucleus actually is moving down, but I want to keep this within that special time. And the nucleus consists of protons and neutrons. And the protons and neutrons reside in the center of the nucleus. That's where they're all jam-packed. All that mass from the two things, the protons and the neutrons, is jam-packed in this tiny center, the nucleus, like the sun. Think of like the sun. jam packed with